for x squared times the square root of 4 minus x squared dx. So the form, what we're focusing on here is the square root of 4 minus x squared. So our form is square root of a squared minus x squared. Alright, so I'm looking at the 4 minus x squared up here. And in terms of my, time out. That looks just like the one right above you, right? Yeah, so that's really not at all what I meant to do. So let me start this over. Example is 1 over x squared times the square root of 4 plus x squared. And that makes this one a plus. Alright. That would have been silly. Okay, so 4 plus x squared. Alright, new form. So this is our a squared plus x squared. So in terms of my two identities that I have up here, if I move things around in the first one, I'm going to have a subtraction sign. And so the one I want to look at is tangent squared theta plus 1 equals secant squared theta. So I might write it as 1 plus tangent squared theta is equal to secant squared theta. And so my idea here is that I'm going to have to multiply this equation by 4. So I'll have 4 plus 4 tangent squared theta is equal to 4 secant squared theta. And then rewrite this equation as 4 plus 2 tangent theta, the quantity squared, equals 2 secant theta, the quantity squared. Okay, are there any questions on how I went from my trig identity, connected it to the 4 plus x squared, and then rewrote that trig identity so it looks like 4 plus x squared? Okay, so that means that I'm going to let x be equal to 2 tangent theta. Now, in terms of our table over here, we are going to identify the form square root of a squared plus x squared with 1 plus tangent squared theta equals secant squared theta. And our substitution will be x is equal to a times tangent theta. Okay, are there any questions about this so far? Alright, our next job is to translate our integral fully into thetas. Now, when I'm doing this, I might go ahead and do some work off to the side with the square root of 4 plus x squared. Since x is equal to 2 tangent of theta, then 4 plus x squared is going to be equal to 2 secant theta squared. Remember, my x is 2 tangent theta. So that means that the square root of 4 plus x squared will be equal to 2 secant theta. So I'm going to go ahead and replace the whole square root of 4 plus x squared with 2 secant theta.
So why is it 4 plus x squared equals 2 secant theta squared?
So I've got my 4 plus, so are you okay with this line right here?
Yeah.
And then this 2 tangent theta, that's my x.
Okay.
And so that means that 4 plus x squared is equal to that guy. Okay, so I've got my integral of 1 over x squared times 2 secant theta. And I still have a dx at the end. So I've made my main substitution, but I still need to take care of the dx. So since x is equal to 2 tangent theta, then dx over d theta will be 2 secant squared theta. So dx is 2 secant squared theta d theta. And since x is 2 tangent of theta, I can replace that x squared with 2 tangent theta quantity squared. So we've got the integral of 1 over 2 tangent theta quantity squared times 2 secant theta times back in our numerator, 2 secant squared theta d theta. Okay, we've turned our integral entirely into thetas. Are there any questions about doing that part? Once you've done one, the second one goes a little bit quicker. All right, our next job is to do some canceling. So anything that we can cancel here? Yeah, the secant. So I can cancel, I've got 2 secant theta. I can cancel the 2 up here and one of the squareds on secant theta. So we end up with the integral of secant theta over 4 tangent squared theta, and then a d theta at the end. Okay. So in addition to canceling, I also distributed my square on my 2 tangent theta. Okay, everything's in terms of thetas. And I have no idea what to do with this guy now. So I'm a little bit sad. But the thing is, I have secants and tangents all over the place, and those are not as nice to work with as sines and cosines. So something I might do here is maybe get rid of these secants and these tangents and write them in terms of sines and cosines. So if I'm going to do that, we've got the integral of 1 over, so secant is 1 over cosine of theta. And in the denominator, oh, I can pull that 1/4 out in the front. I'll go ahead and do that. In the denominator, we have sine squared theta over cosine squared theta. Now, it does look like I've made this worse, but we can multiply by the reciprocal. And so we have 1 over cosine theta times cosine squared theta over sine squared theta, d theta. One of these cosines cancels. And we're left with, so we have 1/4 the integral of cosine of theta over sine squared theta d theta. All right. So you look at this integral here, and you say, what am I going to do with this? So take a look at your neighbor and ask your neighbor that question.
Like you make from sine, do you equal cosine theta to theta?
Yes.
All right, so you've had some time to at least float at least one suggestion with your neighbor. Anybody have any thoughts or ideas on what would they do?
U sub.
Okay, what would you like your u to be?
I would like my u to be sine theta. D would therefore be cosine theta d theta. That'll just turn into 1/4 the integral of du over u squared.
Du over d theta is cosine theta, and we'd be left with the integral of 1 over u squared du.
Right.
Okay? All right, so this can certainly work, so let's go ahead and continue with this. We've got cosine of theta, and so then, let's see here, we've got d theta is equal to du over cosine theta. And so our integral would be the integral 1/4 of the integral of 1 over u squared du, and you can double check that all cancels out there. And so our antiderivative, well, first we'd rewrite the 1 over u squared as u to the negative 2 du. And so we'd have 1/4 times, add 1 to the power and divide by the new power, and a plus c. Okay. Alright, so we've got -1 over 4 times u plus c. And u is equal to sine of theta, so we have -1 over 4 times the sine of theta plus c. Okay. And now we've taken our antiderivative. Okay. Final step here is, okay, now we need to turn this back into x's. So in order to turn back into x's, I need to know my substitution. Everything in this problem hinges on your choice of x. And so this column right here, this substitution, that choice makes or breaks your problem. Okay, so we know that x is equal to 2 tangent theta, which means that tangent of theta is equal to x over 2. Tangent is opposite over adjacent. And so if I draw a picture of my triangle, my opposite side is x, my adjacent side is 2, and so now my hypotenuse is going to be, so my hypotenuse, I call that h, h squared is equal to 2 squared plus x squared, so my hypotenuse will be 4 plus x squared. What's that?
Can you fold this on the overhead right now?
Oh, yeah, this thing way out here. Okay, yes, absolutely. No, better? Great, thank you. Okay, so we now have our hypotenuse here. And so when I go back to my expression up here, I've got -1 over 4 times sine, which is opposite, that's x, over hypotenuse, 4 plus x squared.
Wouldn't it be square root? Yeah.
Oh my goodness, thank goodness you guys are here. Yes, square root of that. And so we could clean this up if we wanted to. We don't have to, but if we did want to clean this up, it would look like negative square root of 4 plus x squared over 4 times x plus c. So either answer is a valid final answer. All right. So these problems are no joke. They pull in all of your trig knowledge, and you may even need to do a u substitution. Yes.
Instead of doing the u substitution,
Right
you
here?
keep the identity of sine squared plus cosine squared and resolve for sine squared, basically. So take your sine squared, and then you have sine squared theta is equal to 1 minus cosine.
Okay.
Right there. Does that also work?
So what are you thinking about doing from there? If it were flipped upside down, that would be nice for me to work with because I could do some simplifying then.
Yeah.
But I think this might give us a dead end, unless there's something else clever that we can do with that. All right, so maybe that one wasn't going to work out for us. Did anybody solve this differently other than a u sub?
Yeah, I split it up. I did cosine over sine, and then 1 over sine. And then I did cotangent over secant, cosecant.
Okay, so you split it like this?
Mm-hmm.
All right. 1/4 the integral of...
Cotangent, and then cosecant. And then I did the derivative, negative cosecant.
Okay, so the antiderivative of this
Or the
is
antiderivative,
going to
yeah.
be negative cosecant theta plus c. Okay? All right, also a valid way to work on this problem. So if you ended up with this as your antiderivative, looks very different Well, not too terribly different from this one up here. I mean, here we had 1 over sine, which is in fact cosecant. So these answers are actually exactly the same. All right, so from here, we would still go to the triangle and find the 3 sides and plug in for cosecant theta. All right, did anybody go about attempting this integral in different from the u sub or different from the trig identity? Both ways are absolutely valid. Okay. All right. So our last table up here, so I'm going to go ahead and erase this trig identity part since I used part of our table here to do that. All right, so our result up here was that the square root of a squared plus x squared ended up being, let's see, what did that guy end up being? It ended up being a secant theta. All right, and our final example. Got the integral of 5 over square root of x squared minus 49 dx. Now, this one looks very similar to the first one, and you might be saying, Diane, you're repeating yourself again. But I'm not in this time. This time, the difference is that the variable is first, and then we're subtracting off the number. Okay? So our form is square root of x squared minus a squared. In our example, a is equal to 7. Okay, so thinking about these two identities that I have sine squared theta plus cosine squared theta equals 1, and I have tangent squared theta plus 1 is equal to secant squared theta. Now, in terms of what we have, I want to be able to write variable minus number equals a variable that's positive. And so to make that happen, if I move around the sine squared plus cosine squared equals 1, then I'm going to have a negative cosine squared on the right-hand side. So I don't want to do that. Rather, I'm going to work with my second one. So I'm going to look at secant squared theta minus 1 is equal to tangent squared theta. So when I see square root of x squared minus a squared, I want to identify this with secant squared theta minus 1 is equal to tangent squared theta. All right, now we want a variable squared minus 49, which means that I need to multiply everything in this equation by 49. So 49 secant squared theta minus 49 is equal to 49 tangent squared theta. And then this first term I can write as 7 secant of theta, quantity squared, minus 49, is equal to 7 tangent squared. Or, well, 7
Wouldn't it be minus 7?
So I could write this as minus 7 squared if I wanted to.
Okay.
So either minus 49 or minus 7 squared. But what I want is something that looks like x squared minus 49. Okay, so I've taken my original identity and I've multiplied it by 49 to write it in a format that is variable squared minus 49. So my choice for x is going to be 7 secant theta. So in general, for our substitution, we'll let x be equal to a times secant theta. Now some work that I need to do, and I might as well do it right away and get it out of the way, is I'm going to need to know dx. And so dx will be 7 secant theta tangent theta d theta. And the other piece of work that I'm going to want to do is that x squared minus 49 is going to be equal to 7 tangent theta quantity squared. And so when I take the square root of both sides, we end up with square root of x squared minus 49 is equal to 7 tangent theta. So our final result over here in our table is that the square root of x squared minus a squared is going to be equal to a times tangent theta. Okay, are there any questions on all of our salad bar work over here?
Where did you get the 7 tan theta below the dx? Like, where did that come from?
Here?
Yeah, so where did you come up with the 7 tan theta squared?
Secant theta's integral is secant tangent.
So this guy here, that without the square roots, this is our x squared minus 49 equals
Oh, so you
that
got it
guy.
from the left, okay,
Yeah.
gotcha, I'm good.
Yeah, so this one was, yeah, that was confusing, unrelated to calculus.
And that top one, the dx is just the, yeah, but how did you get that?
Oh, how did I get that? So I looked at my derivative of secant theta.
Because you secant tangent.
Good.
Yeah, and then you just added the d theta.
So that step that I jumped on was this is really dx over d theta equals that, and then I bumped it over. Okay, other questions? These are good questions, because I'm definitely skipping some steps in this one.
Yeah, you just did the integral, right?
What's that?
That's just the integral step.
That's right, we haven't actually done any calculus yet. We've only done trig. Oh, no, we did do calculus, we took a derivative up there. Okay, so let's go back to our integral. We have the integral of 5 over 7 tangent theta times, okay, dx is 7 secant theta tangent theta d theta.
Wait, is our x secant?
What's that?
So isn't our x secant 7x or 7 secant?
Yes, so what I could have done here is I could have plugged that in here for x.
Oh, okay, I see what you did.
But yeah, what I did is I did all that work off to the side, made that whole substitution there. Good, are there other questions? All right, so now we can look at this and say, okay, everything's in terms of thetas. What can we cancel? We can cancel the 7s, cancel the tangents, and we're left with the integral. I'm going to pull the 5 out in front. We've got 5 times the integral of secant theta d theta. All right.
Nice.
Yeah, so this integral is one that I asked you to add to your list, that you maybe used a whiteboard marker and marked it up on your bathroom mirror so you could look at it when you're brushing your teeth. Take a look at your neighbor and remind them what the antiderivative of secant theta is. And if you don't remember, hopefully your neighbor does. And if your neighbor doesn't, then look it up.
Can I cheat you? Really? Really? No, you cannot.
Write that down.
I don't want to hug you. I don't want to cuddle you. I want nothing to do with you.
All right, so has anybody been brushing their teeth and looking at this integral?
I do too.
Okay. Does anybody have it written in their notebook?
Yes.
They can recall. Then what did you come up with?
The absolute value of secant theta plus tangent theta.
All right, so this is one that, this integral of secant theta does pop up, especially in these trig substitutions, so this is a good one to remember. So we have 5 times the natural log of secant theta plus tangent theta. Okay, so we've taken our antiderivative. Are there any questions on this part? All right, turn it back into x, that's our final step.
Probably do 2 steps.
All right, so what do we know? We know, so back into x's. We know that x is equal to 7 times secant theta, so that means secant theta is equal to x over 7. Secant is the reciprocal of cosine, so we have hypotenuse over adjacent. So when I draw my picture, I've got my hypotenuse is x, my adjacent is 7, and I need to figure out my opposite side. Okay, so let's see, we've got 7 squared plus opposite side squared is equal to x squared, which means that our opposite side squared is x squared minus 49. So our opposite side is square root of x squared minus 49. All right. Once we've got that information, we can go back to our integral, and we have 5 times the natural log of secant, which is adjacent, or hypotenuse over adjacent, so our hypotenuse is x, over adjacent, which is 7, plus tangent, which is opposite, square root of x squared minus 49, over adjacent, which is 7. And this is our final answer. 5 times the natural log of x over 7 plus root x squared minus 49 over 7 plus. Wow. Okay. Are there any questions on the what part of this?